Hi everyone and welcome to MathSux. This video is going to help you pass the Geometry Common Core Regents. We're doing this one question at a time. Here's question 1. In the diagram below, triangle ABC is reflected over line L to create triangle DEF. So notice that we have the mirror image here. These two triangles are going to be equal to each other, and they are reflected over this line L. So if angle A equals 40 degrees, angle B is 95 degrees, what is angle F? So if we bring this to the other side when we reflect it, the mirror image, we see that angle A corresponds to angle D, so we know that this is going to be 40 degrees, and that angle B corresponds to angle E, we know this is going to be 95 degrees. But they want to know what the value of this angle F is, so what we're going to do is just add together 40 plus 95, which is 135, subtract that from 80, and we're left with 45 degrees. So angle F is 45 degrees, which is choice 2. The degrees within a triangle always add up to 180, so that's why we knew to do this. Question number 2. The diagram below shows triangle ABC, so this big triangle here, ABC, with point X on side AB and point Y on side CB. Which information is sufficient to prove that triangle BXY, so this inside triangle here, BXY, is similar to BAC? So we're looking to prove that the two triangles are similar. So the way to prove triangles similar is by either angle, angle, side, 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 or side, angle, side. So if you notice, if you look at our triangle, if you look at both of our triangles, triangle ABC and triangle BXY, notice that they share this angle B here. So already we have an angle. So all we would need is another angle or possibly two sides. So we already know this is probably not going to be it. So we're going to be looking at these answer choices and seeing if we get a side or it can get more angles. So which information is sufficient to prove that these two triangles are similar? Angle B is a right angle, so we already know they're equal. It doesn't matter if it's a right angle or not. The value doesn't matter, so that's not going to give us any information. That's not going to give us the right information. XY is parallel to AC. So when two lines are parallel, it's actually and are cut by a transversal, which in this case would be BC and AB. It creates like a transversal and all these angle relationships. So we would know that different angles are equal to each other. So if we know that these are parallel, that would tell us that this angle would be equal to this angle, and this angle would be equal to this angle. So knowing that, we could say that choice 2 is our answer. Question number 3. Quadrilateral math is congruent to quadrilateral WXYZ. Which statement is always true? So MA is equal to XY. So when we have a quadrilateral, that could be any shape. So that could be a parallelogram, or it could even be a trapezoid, because that's also a quadrilateral, right? So if we have this shape here, the sides aren't always going to be equal, so no. Angle H is congruent to angle W. Again, we don't know what the angles are of math or what shape it even is, so no. Choice number 3. Quadrilateral WXYZ can be mapped onto quadrilateral MATH using a sequence of rigid motions. Yes, that sounds right, so let's just leave it open. That sounds right. So if we were to flip and rotate and then transform our trapezoid or quadrilateral parallelogram or any quadrilateral shape, it would be able to map it onto itself using rigid motions. And then choice 4, quadrilateral math and quadrilateral are the same shape but not necessarily the same size. We already know that they're going to be congruent, so they would have to be the same size. So choice 3 is our answer. Yeah, that keyword being congruent and rigid motions will maintain the congruency of this shape. Question number 4. A quadrilateral has diagonals that are perpendicular but not congruent. This quadrilateral could be, so when you think about a square, the diagonals are going to be congruent, right? So that's not our answer. But when you think about a rhombus, the diagonals, so even though I'm saying think about, there's properties that you may have to go over again or memorize to be able to answer this question. So you can see here that depending on the shape of the rhombus, the diagonals are not congruent. So this is choice 2. In a rectangle, the diagonals are congruent, and in an isosceles trapezoid, where it's equal lengths on both sides, the diagonals are also congruent. So our choice is number 2, a rhombus. Question number 5. Which regular polygon has a minimum rotation of 36 degrees about its center that carries the polygon onto itself? So this can be any shape a polygon is, like any enclosed shape. So we can have a pentagon, an octagon, nonagon, decagon. And so the way we're going to find this is if we have a shape which contains 360 degrees within a polygon, so that's every shape has 360 degrees inside. Basically, you can draw a circle in the shape, right, which contains 360 degrees. Now, if the minimum rotation is 36, we're just going to divide up the 360 degrees divided by 36, and now this might look pretty easy. This is just going to be 10, right? So we know that this shape is going to have 10 sides because we have to rotate it 10 times. So the shape associated with a 10-sided figure is a decagon, meaning this means 10. So that's our answer. Question number 6. In the set of axes below, triangle RST is the image of triangle ABC after a dilation centered at point P. The scale factor of the dilation that maps triangle ABC onto RST is. So we're going from this big triangle ABC, and then we're making it smaller using a dilation. So we know we're going to make something smaller, so we know we're going to be using a fraction. So already we can cross off choices 2 and 3. So let's just pick a point that are associated with each other. So it's clear that point R goes to point A, right? So let's pretend P is our origin, and let's count where point A is in reference to that. So we have 1, 2, 3. So we have point A is -3, and then down 1, 2, 3. So -3, -3. And then we dilate it by some amount, we don't know yet. And let's see where R ends up in relation to P. So this is -1, -1. So now we just need to ask ourselves, what are we doing to this 3 in order to get 1? So -3x equals -1. Just divide that, and we get x is equal to 1/3, which is choice 1. Question number 7. In the diagram of triangle ABC below, angle C equals 90 degrees, CB is 13, and AB is 16. What is the measure of angle A to the nearest degree? So we want to find out angle A. And what we're going to be using here is SOHCAHTOA. So if you look in terms of angle A, we have the opposite, and we have the value of the hypotenuse. So the opposite and the hypotenuse, that means we're going to be using sine. So sine of A, we don't know what it is yet, is equal to the opposite, 13, over the hypotenuse, which is 16. So to plug that in our calculator, we're just going to make sure we're in degree mode, which we are, and then we're going to go second sine, or arc sine, 13 divided by 16, and then we get this number, 54, that's about 54 degrees, which is choice 4. Question number 8. The pyramid of Memphis in Tennessee stands 107 yards tall and has a square base whose side is 197 yards long. What is the volume of the pyramid of Memphis to the nearest cubic yard? So before we start calculating anything or write a formula, I'm just going to draw this out. So remember, this is a square base pyramid where the height is 107 yards and the base is 197. So since it's a square base, we know that this is 197 over here, and all around. So the volume for a square base pyramid is 1/3 base squared times the height. So we're just going to plug in our numbers here. 1/3, the base is 197 squared times the height, which is 107. And now we just need to plug this into our calculator. So we get this value here. And they want it to the nearest cubic yard, so that's like the nearest whole number. So this will just be 1,384,188, rounding up because of this 0.6, which is choice 2. Question number 9. A square is graphed on the set of axes below with the vertices at -1, 2, -1, -2, 3, -2, and 3, 2. This transformation would not carry the square onto itself. So we want to carry this square onto itself perfectly. So if you look at choice number 1, a reflection over the y-axis, here's the y-axis. If we were to reflect this point over, it would not be onto itself perfectly anymore, right? So number 1 right away is actually going to be our answer. If you could see the difference, if you look at the next choice, reflection over the x-axis, if we were to fold up this x-axis, notice the square is perfectly symmetrical about the x-axis. So that means it'd be reflecting and it would look exactly the same, which is exactly onto itself. So we know that that is not the answer. And if you look at these other two choices, answer choices, the same thing would happen. So choice 1 is our answer. Question number 10. If a scalene triangle XYZ is similar to triangle QRS, and angle x equals 90 degrees, which equation is always true? So first, let's draw out these two triangles. So scalene, remember, means a triangle with all different side lengths. So we have a triangle that looks something like this. We have angle x is equal to 90 degrees of triangle XYZ, so YZ. And then we have triangle QRS. We're saying it's going to be similar to this other triangle. So here we're going to have Q, because here X was 90 degrees, so now Q is going to be 90 degrees, and we have RS. So they're saying which equation is always true. So we could run through each choice, answer choice, using SOHCAHTOA. Or you could notice right away that choices 1 and 2 are not cofunctions, right? We're going to want one cosine and one sine, so on either side of the equation. So we're just going to cross those out, choices 1 and 2. So that brings us to choices 3 and 4. So let's look at choice 3 first, which says cos of y is equal to sine of q. So cos of y, so if we look at y over here, we want the adjacent over the hypotenuse. So the adjacent of y is xy over the hypotenuse yz. And we're saying, is this equal to the sine of q? So if you look at q, it's actually the right angle here. So that's already kind of looks weird, because the opposite of q in this case is the hypotenuse. So this would end up being the hypotenuse, RS, over the hypotenuse again, RS. So we know that this doesn't make any sense. This can't be our answer. So the only answer by the process of elimination is choice 4, but let's look at 5. So we have sine of r is equal to cosine of z. So if we look at r, which is over here, so we want the sine, which is the opposite qs, over the hypotenuse rs. And we're saying that's equal to the cosine of z over here on the other triangle. Cosine is adjacent xz over the hypotenuse yz. So this is equal. So if you notice, we have qs, which is this area down here, and we're saying it's equal to xz, which is this area down here, the base of the triangle, So that matches up. And then we're saying that rs, the hypotenuse, is equal to yz, the hypotenuse over here in this other triangle. So that's how we know that this is the right answer, because each side is in proportion to one another. Because this is a similar triangle, we know that we're going to be looking for something that's in proportion to one another. So that's our answer. Question number 11. A plane intersects a cylinder perpendicular to its base. So perpendicular means we're going and making a right angle to the base. So the base is going this way, so that means we're going to make a plane going down like this way. This cross section can be described as a rectangle. So if we were to intersect this plane, notice going down the middle, perpendicular to the base, it creates a rectangle. Question number 12. An equation of line P is y equals 1/3 x plus 2. An equation of line Q is y equals 2/3 x plus 8. Which statement about lines P and Q is true? So with dilations, there's a couple of different rules to remember. That when a line is dilated about the origin, it's going to form a parallel line. So knowing that, if we look at our slopes here, 1/3 and 2/3, we can see that the lines are not parallel. So we know that they're not going to be able to map onto each other. So knowing that, let's just go through the answer choices. Which statement about lines P and Q is true? A dilation of 1/2 centered at the origin will map line Q onto line P. So we know that's not true because these lines aren't parallel. Choice number 2, a dilation of 2 centered at the origin will map line P onto line Q. So again, no, this isn't going to work. These lines are not parallel. Line Q is not the image of line P after dilation because the lines are not parallel. Yes, yeah, this follows along with the rules that we should know, and this is our answer. On to question 13. The coordinates of the endpoints of SC are -7, 3, and 2, -6. If point M is on SC, what are the coordinates of M such that SM is in proportion to MC is 1 to 2? So this is a formula there's a formula we're going to use for this kind of question. So before we even write the formula out, I'm just going to label our points. So we have our one coordinate, -7, 3. We'll call this x sub 1 and y sub 1. We also have this other coordinate, C, 2, -6. Let's call this x2, y2. And then we have a proportion 1 to 2. Let's label this A to B. So now I'm going to write up the formula. So we're going to notice if we look at the answer choices, we have a coordinate. So we're going to be doing the formula twice, once for x and once for y. So let's do it first for our x coordinate. So this is our formula for the x coordinate, and now we're just going to fill it in with what we have up here. So x1 is -7 plus a, which is 1 over a plus b, 1 plus 2, times x2, which is 2, minus x1, which is 7, so we can just do plus -7. So we'll get plus 7, and this will give us so we get x is equal to -4. So right away, actually, you can see that choice 1 is going to be our answer because that's the only answer choice with the value of x being -4. And if you wanted to do this for the y coordinate, just for practice, we're just going to do the same kind of formula but using y now. So we get y1 plus a over a plus b, y2 minus y1. And then we're just going to fill in with our formula from up here, from the numbers up here. y1 is 3 plus, this will be 1/3 again, times y2, which is -6, minus y1, which is 3. So you'll plug that in your calculator and you'll end up with 0. Question number 14. On the set of axes below, rectangle wind has vertices with coordinates -4, 2, 4, 0, 3, -4, and d, -5, -2. What is the area of rectangle wind? So there's a couple of different ways to do this. So we're going to find the area, right? So that means we're going to need the length and the width of this rectangle. and it's not perfectly aligned with the coordinate points. So you can either use the distance formula to find the distance between each point, and then you'll find the width and the distance between these 2 points to find the length, and you can multiply them together. Or you can even notice that this kind of forms a triangle, and then you can use the Pythagorean theorem to find the missing value. So there's triangles on both sides. So if we look at this triangle first, you'll see that it's 1, 2, 3, 4, 5, 6, 7, 8 units long and 2 units this way. So if we use the Pythagorean formula, a squared plus b equals c squared, we'll get 8 squared plus 2 squared. We'll get c is equal to radical 68. So that this value of this length is equal to radical 68. Now if we do the same thing over here, looking at this triangle that drops down, this is also a right triangle. 2, 3, 4 on this side, 1 on this side. So if we do the Pythagorean theorem again, we'll get 4 squared plus 1 squared equals c squared. So we get c is equal to radical 17, which is going to be our width. So now to get the area of the rectangle, we're just going to multiply length times width, which is radical 68 times radical 17. So plug that into your calculator and you'll get radical 156, which happens to be a perfect square, which is 34. Which is our answer, choice 4. Question 15. In parallelogram ABCD shown below, EB bisects ABC. If angle A is 40, then BED. So we're going to want to try and find this angle right here, angle BED. So a parallelogram has opposite equal angles here, so 40 degrees is A, so we know that the opposite is going to be 40 degrees at angle C. All the degrees within a parallelogram add up to 360, so if we have 360 minus 80, just adding, because we already know we have 40 and 40, we're left with 280, so that means there's 280 degrees left between D and B, so we're going to divide that by 2, so 140 degrees is over here, and then 140 divided by 2, remember this angle is being bisected by EB, so we know that 70 degrees is over here and 70 degrees is over here to add up to 140. So now we're almost done. So within a triangle we need 180 degrees, so we have 70 plus 40 gives us 110, 180 minus 110 gives us 70 degrees here, and then this is a straight line, so we know that 180, this is also going to have to add up to 180. So we're going to do 180 minus 70, and we get 110 degrees, which is choice 3. Question 16. In right triangles ABC and RST, hypotenuse AB equals 4 and hypotenuse RS equals 16. If triangle ABC is similar to triangle RST, then the ratio 1 to 16 is the ratio of the corresponding what? The legs, the area, the volume, or the perimeter. So let's first draw this out. So we have right triangle ABC where it says hypotenuse AB equals 4. So here we have AB, the hypotenuse, and we're just going to label it 4. And now we have another triangle, triangle RST, where RS is the hypotenuse, which is equal to 16. Okay, so now we want to know then 1 to 16 is the ratio of the corresponding what? So this question is weird because it doesn't really give you enough information. So in order to answer the question, we're just going to have to assume that these two triangles are isosceles in order to find the side length values. So we're going to have to assume that these two sides are equal. So these two legs are equal, within this triangle, and then these two legs are equal in this triangle. Otherwise known as the 45, 45, 90 degree triangle. So, okay, so now that we know, or we're assuming that we have a 45, 45, 90 degree triangle, that means that these two values are going to be the same. So the value of this leg is going to be equal to the value of this leg. So based on that, we can actually find what these legs are because we have the hypotenuse. So we have our typical a squared using the Pythagorean theorem. A squared plus b squared equals c squared. But now we have L squared plus L squared is equal to 4 squared. So just using a little algebra, we can figure this out. This becomes 2L squared is equal to 16. And then just simplifying this radical, we can break it down to radical 4 times radical 2. And radical 4 is just 2. And then we're left with this radical 2. So this leg is equal to 2 rad 2. And this leg is equal to 2 rad 2. So now let's try to find the value. Let's do the same thing and find the value of the missing side length over here. So same thing. A squared plus b squared equals c squared. When we simplify this, we're going to get radical 64 and radical 2. Radical 64 can be simplified, is a perfect square, can be simplified to 8, and then we're left with this radical 2. So now we have the side lengths of this other triangle, which is 8 radical 2. So now we can go back and look at our question. We're looking for the ratio of 1 to 16, that's the goal, and we're going to compare the legs first. So let's look at the legs. So if you look at the legs of the triangle, we have 2 rad 2 for this triangle, triangle ABC, and then for triangle RST we have 8 rad 2. So if you plug that on our calculator or just divide it, 2 divided by 8, you'll see that we get 1 to 4. 2 divided by 8 is 1 to 4, and the radical 2's cancel out, and we get this ratio of 1 to 4. So that's not 1 to 16, which is our goal. So we know that the legs are not our answer. Area. The area of a triangle equals 1/2 base times height. So for this triangle, this first triangle, triangle ABC, we have the area is equal to 1/2, and the base times the height, they're equal to each other, right? These two lengths are equal, so we can just square them. So that's 2 rad 2 squared. So rad 2 times rad 2 is just 2. And then 2 to the second power is 4. So inside here we get 4 times 2. 8 divided by 2 is 4. So the area of triangle ABC is 4. So now let's find the area of our other triangle, triangle RST. So we have the same thing where it's 1/2 base times the height, and notice we have the same base. The value for the base is the same as the height, which is 8 rad 2. So we're just going to do this squared. 8 squared is 64. Radical 2 squared is just 2. This gives us an area of 64 for our second triangle, triangle RST. So now when we put them, let's bring our areas down and see how they look when they're in ratio form, 4 to 64. So it looks like we can reduce that. And when we do, we get 1 to 16. So you can just plug this in your calculator and see that it reduces, or you can notice that you can divide 4 divided by 4, 64 divided by 4, and we get 1 to 16. So we know that the area, choice number 2, is our answer. Question 17. Parallelogram ABCD with diagonal DB is drawn below. Line segment EF is drawn such that it bisects DB at M. Which triangle congruence method would prove that triangle EMB is congruent to triangle FMD? So first, right away, I want to start marking this up. We have a vertical angle here. But we also were given information about line segment EF that was drawn to bisect DB. So that means that these two line segments are equal to each other, or these two sides of the triangle are equal. We can also, because this is a parallelogram, it says it's a parallelogram, that means that opposite sides are parallel, and because of that we have a transversal. So we can say that angle D is congruent to angle B. And we can also say angle E is congruent to angle F. The blue lines are just based on transversals. So if we look at what we're trying to prove congruent, we have triangle EMB. So EMB, this triangle right here, to FMD. We can prove that by doing angle, side, angle. And we could also do angle, angle, side. So we can do it both ways. So this is going to be choice number 3. Question 18. In the diagram below of circle O, chords AD and BC intersect at A, and chords AB and CD are drawn. Which statement must always be true? So here we have intercepted arcs. Notice angle A and angle C both intercept arc BD, so that means they're going to be equal to each other. So we're just going to be looking for something that says that, which is choice 3. So if you, just for a little explanation, I'm just going to put this on the side. Angle A is congruent to angle C because both inscribe angles intercept the same arc BD, which is right here. Question number 19. What are the coordinates of the center and length of the radius of the circle whose equation is x squared plus y squared minus 12y minus 20.25 equals 0? So here we're going to be completing the square. And I have videos and a bunch of practice questions on this if you want to review how to complete the square. So first thing is I'm going to rewrite the equation. And now I'm going to bring this whole number to the other side of the equal sign. So notice I left some space here. We're going to be adding a number in these boxes, the same number. So we're going to take this value, minus 12, divide it by 2, and you get negative 6. Then we're going to square that, which is 36, and that's what we're going to put in our boxes. Now on this side of the equation, I'm going to keep the x squared the same, and I'm going to rewrite the y section of this equation. So instead of having y squared minus 12y plus 36, you can actually rewrite this entire thing by using y minus 6 squared. And I just got the minus 6 from what we did in this section and just brought it down. I'm going to add these two together and we get 56.25. And now this is really our circle equation, and now we just need to read it right. So based on this, we can say that the center is 0, and then we always want to do the opposite of this. So the x value is 0 because there's no numbers associated with this x squared. And then here we're subtracting 6, so really y is at 6. So our center is 0, 6, and then our radius, we're always going to want to take this value, the whole number, and take the square root of it. So when we do that, we'll get 7.5. So now we just need to find the answer that aligns with this. So here we have the radius 7.5, and now the center is 0, 6, the first one, so it's choice 1. Question 20. In the diagram below, ABCD is a rectangle, and diagonal BD is a drawn line L, a vertical line of symmetry, and line M, a horizontal line of symmetry, intersecting at point E. Which sequence of transformations will map triangle ABD, so this triangle ABD, onto triangle CDB? Triangle CDB. So we're trying to get this triangle to map onto this triangle. Just to use like a visual aid, I made a rectangle and then cut it diagonally across what would be BD, so we have these two triangles. So you can see that we're going to want to try and map this onto this triangle. So let's see how we're going to do that. Let's go through each answer choice. Choice number 1, a reflection over line L followed by a 180 degree rotation about point E. So a reflection over line L. So line L is this way, so it's the long way. So we're always going to be moving triangle ABD. That's this triangle right here. So we're going to be only moving this one and searching to map it right onto this one. This one stays stationary. So a reflection over line L would make this triangle ABD go this way, followed by a 180 degree rotation about point E. So point E is in the middle, and then if we did 180 degrees, we're just going to be turning it all the way around, and we can see that this doesn't map onto the other triangle. So let's set it back and see about choice 2. Our reflection over line L, so we're going to do the same thing. We're just going to flip it over line L, followed by a reflection over line M. So now we're going to be flipping it again the long way because M is going horizontally. It's kind of like a reflection over the x-axis. And when we do that, notice it maps onto our other triangle perfectly. So choice number 2 is our answer. Question 21. The diagram below models a countertop designed for a kitchen. The countertop is made of a solid oak and is 3 inches thick. If oak weighs approximately 44 pounds per cubic foot, the approximate weight in pounds of the countertop is. So notice before we do anything, just be careful of the units of measurement. So here we have feet, 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 and then we have inches over here and inches over here. So before we do anything, let's just convert the inches into feet. So there's 12 inches in 1 foot, so we can say that these are like 3 out of 12. So that's like 3/12 of a foot. We're going to be finding the volume and then multiplying it by 44 pounds to see how heavy this countertop is. There's going to be 2 parts to find this on, because notice this is an interesting looking shape, right? The countertop, we can split it up into 2 rectangles. So this whole thing is 10 feet. So I'm just going to cut it off right here. And then this whole thing this way is 12 feet. But because we have to cut it off and want to separate into different sections, we're going to subtract 3 from 12 to get 9 feet. And I subtracted 3 just because the width of this right here left over is 3 feet. So now we can find the volume. So I'm just going to label this A and B. So the volume of A is just going to be 10 times 3 times 3/12, which will give us 7.5. And the volume of B is going to be 9 times 3 times 3/12, which is going to give us 6.75. And now the volume altogether of this shape is equal to 7.5 plus 6.75, which is 14.25. So they're not just asking for the volume, they want to know specifically how heavy the countertop is. So they give us the pound per cubic foot, so this is feet cubed, right? 14.25 feet cubed. So per cubic foot we have 14.25 just times the weight, so times 44, which will give us 627. which we can say if you look at our answer choice is closest to 630. So that is pretty close. So choice 1 is our answer. Question 22. In the diagram below of triangle ABC, TV intersects AB and AC at points T and B respectively. And angle ATV, so they're giving us information, angle ATV is equal to angle ABC. If AT equals 4, BC equals 18, TV equals 5, AV equals 6, what is the perimeter of quadrilateral TBCV? We can see that these two triangles, triangle ATV and triangle ABC, are similar by angle, right? Because they share angle A, and then they share, which they told us, they have an angle here, angle T is congruent to angle B. So we know by angle, so because of that, because they're similar, that means they're going to be in proportion. We're finding the perimeter of quadrilateral TBCV. So I'm just going to draw that down here. So we have TBCV. And to find the perimeter of this trapezoid within here, we need all the sides. So we have 5 over here and 18 over here. And then we're going to need to find the missing sides from BC and TV. So let's get started. So we're going to make proportions. So let's find this VC missing side first. So we're just going to do that by making a proportion. So we'll have 4 to 6 is equal to 5 over x. Let's label it VC so we don't get confused. So and then we're just going to cross multiply. We get 4 VC. And then we get BC is equal to 7.5. I'm just filling it in up here and then down here in where we focus on the quadrilateral. So we found that missing side. Now let's make another proportion to find this other missing side, TV. So to do that, we're going to get 4 over TV is equal to 5 over 18. Cross multiply, and we get 72 is equal to 5 TV. Divide by 5. And we get TV is equal to 14.4. So let's fill that in. So this part right here, TV is 14.4. Now to find the perimeter, we just need to add up all the sides together. So we're going to be adding 5 plus 14.4 plus 18 plus 7.5. And when we do that, you plug that in your calculator and you end up getting 44.9, which is choice 4. Question 23. A circle centered at the origin passes through A, which is -3, 4. What is the equation of the line tangent to the circle at A? So a tangent to the circle, that means we're going to be next to the circle and we're going to be including that point A. So it's going to have this -3, 4. The way to think about this is that we're going to want a line that is perpendicular, because a line tangent to the circle is perpendicular to the radius and forms a right angle. So knowing that, we can actually find the slope that is formed from the origin to this point and then find a slope that is perpendicular to that, which will be the slope of this line. So first let's find the slope of this line here that forms from the origin to the end point of the radius, -3, 4. And when we do that, we're going to get 4 minus 0 all over. So now we want a perpendicular line. Now we want a perpendicular slope, which is going to be the negative reciprocal of this number. So the negative reciprocal of this, that means we're going to flip and negate. So we're going to have 3 over 4, and then we're going to negate it. It's a negative, so now it's going to be positive. So we know that the new equation of the line is going to have this slope. So if you look at, so this number right here represents slope, and y-intercept form. So actually, let me write out y-intercept form formula also. So we have y minus y1, where m is the slope. So we're looking for something here that has 3/4 as the slope. So right away you can see that choices 1 and 3 don't have that, right? They have 4/3. We want 3/4, which these both have. So how do you know the difference between numbers 2 and 4? So that's where the point comes in that they gave us. So the point -3/4 also fits into this formula. We're going to be negating the points as well. So this is because we're using minus signs in the formula. So we have minus. This is y minus 4 because that's the y in our coordinate point that they give us. Setting it equal to the slope 3/4 times x minus -3, which will just give us +3. So we're always going to be negating those values in point slope form and what they give us. If you look at the difference between 2 and 4, you'll see that our answer matches up with choice 2. And that's our answer. Okay, last question on part 1, question 24. In the diagram below, quadrilateral ABCD is inscribed in circle O. Angle A is 2x degrees, angle B is x minus 10 degrees, and angle C is x plus 15 degrees. What is angle D? So the big thing here is a rule where opposite angles in a quadrilateral within the circle are supplementary. Meaning that they add to 180 degrees. So that means angle A plus angle C is going to give us 180 degrees, and angle D plus angle B will also give us 180 degrees. So they give us angle A and angle C, so let's add those together. So we get a value for x, which is 55 degrees. So now let's just plug that into our next formula. So we have angle D, which we don't know what it is yet. So we have angle D plus angle B, which is x minus 10, is equal to 180 degrees. But we know what x is now. We know it's 55 degrees, so we can plug that in. And once we solve for D, we see that it's equal to 135 degrees, choice 4. And that's our answer. So this is the end of part 1. Look out for part 2 coming out soon. So if you're looking for more on this test, check out the playlist in the link below. And thanks for stopping by. Happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!